In this lesson, we will solve exponential equations. To solve exponential equations, sometimes we have to use our properties of law. These are also found on your sheet with the properties. Now, we are going to just solve exponential equations today. So, we have two types of exponential equations to solve, when our bases are the same and when they are different. We have already solved exponential equations when bases are the same. We know that we set the exponents equal to each other and then solve the equation. What's new is solving equations when the bases are different. In another lesson, we will explore solving log equations. Let's look at the first example when our bases are the same. In this problem, it looks like they are different, but we can rewrite the 8 and the 4 so that both have a base of 2. Then we just equate our exponents and solve the equation. And of course, we get x equals 2. We have solved equations like this in coordinate algebra and during class. We always want to do a check to make sure that we have solved the equation correctly and that we don't have any extraneous solutions. And of course, x equals 2 is the solution because it does check. Now, in example 2, our bases are different and there's no way that we can rewrite the 8 or the 23 so that they will have like bases. So when this happens, the first thing we want to do is isolate the power. Next, we want to rewrite the equation in log form. Now, we want to use our calculator to find the value of x. If your calculator does not have the log base feature, then you're going to have to use the change of base formula to solve for x. And of course, x is approximately 1.51. Now we do want to do a check, but notice that this is a rounded solution. So when you do a check, you may want to use the unrounded solution, because when you use the rounded solution, it may not come out to be exactly right. Now, again, here's another exponential equation, and our bases are different. We have a base of e. Remember, e is an irrational number, and we have a base of 72, and there's no way that we can write them so that they are the same. So when that happens, of course, we want to isolate our power, and it's already isolated. Then, because we have e, we want to use natural logs to solve this. So we want to take the natural log of both sides of the equation, and that looks like this. Next, we want to apply our properties, and then we will get this. And now we can use our calculator to find the natural log of 72. And it is approximately 4.277. And of course, we do want you to do a check. In the next example, we see that the bases are different. So we still want to isolate our power first, and our power is 2 to the x. So that means we need to move the 3 by dividing by 3 on both sides, and we will get this. Now, we want to rewrite our equation in log form, which gives us this. At this point, we will use our calculator. Again, if you have the log base feature, you can go ahead and enter in log base 2 of 14 to find the value of x. If not, then you will need to use the change of base formula. And x is approximately 3.807, and of course, please do a check. In our next example, we have an exponential equation. Our power is 3 to the 2t minus 5. And again, we want to isolate that power by adding 4 to both sides first. Then we're going to divide by 2 on both sides, which leaves us this. Next, we're going to rewrite this equation in log form, and we will have this. At this point, we can now isolate the variable t. And to do that, we would add 5 to both sides. and then we would divide both sides by 2, and now we will just use our calculator to get the solution for t, and t is approximately 3.417. And of course, please do a check. Now, I want you to try this problem. After you try this problem, please do a check. And if you have any questions about anything during this presentation, please bring all questions to the next class